In this video, we're going to talk about a series of functional group reactions, acyl transfers. And you're on the first couple, first four actually, you're going to see esters undergoing hydrolysis, base hydrolysis, thiol esters going under hydrolysis, and amides going under hydrolysis. As you can see, the common theme are the similar structures here. True esters in the first two, a thiol ester in the third, and an amide in the fourth. And in the last two, we're going to go the opposite way, using catalysts to put these together. So, taking a look here, let's try naming some of these. We have, let's see, the ester right here. The ester part has two carbons, so this is going to be ethanoate. And on this side we have an ethyl group, so it's going to be ethyl ethanoate. All right, so this bond, the ester bond, is going to split right there. And when we add water, and we're going to have to split water into HOH. And on the carbonyl side, we're going to see the OH bond, so we're going to form a carboxylic acid. And on the opposite side, we're going to have the hydrogen react with that oxygen right there, forming an alcohol. So in this case, ethyl ethanoate undergoing hydrolysis is going to form, let's see, we have a carboxylic acid, so ethanoic acid. And we have ethanol. Okay, so pretty straightforward. Now here we also have the same reactant. We have ethyl ethanoate again, and this time it's undergoing base hydrolysis. So as a result, this is if we have an ester and we see a strong hydroxide like sodium hydroxide like lye, this is a soap making reaction. This is saponification, and we're going to see this on a separate video of the saponification of triacyl glyceride, animal fats, the old way of making soap. Kind of dirty and somewhat nasty, but it's how they did it back in the olden days. So we're going to have a base hydrolysis here of the same ethyl ethanoate, and instead of an ethanoic acid, we're going to have NaNO. So the sodium and the oxygen is going to add to the carbonyl side, and you're going to form one of those soap molecules, one of those detergent molecules right here. And this would be when you have the acid without the H, so the oxygen has a negative charge and the sodium has a positive charge to it, you have basically this hydrophilic group which can dissolve hydrophilic molecules. But then, as you'll see, especially in the saponification reaction video, this end will be typically hydrophobic, so it can dissolve the oils and the greases. So you have a molecule that can dissolve the hydrophobic groups and have the head group, so water can dissolve the entire micelle, and you get rid of your stain. On the opposite side, again, we have ethanol, because we only had the H left over from sodium hydroxide. All right, going to the next one, here we have a thiol ester. We're going to go undergo hydrolysis. It's going to approach the same way as we did in number 1. So on the carbonyl side, we're going to see ethanoic acid again. But on the right side, we're just going to have a simple thiol. In this case, it would be ethane thiol. All right, and finally, we have number 4. This is an amide. All right, so let's see. We have a methyl group attached to the end, so this is going to be N-methyl. And we have the amide is an ethane group. All right, so N-methyl ethanamide. All right, it's going to break in the same spot here. We're going to get the hydrolysis going on. We're going to have the OH, of course, add to the carbonyl side, and we're going to form ethanoic acid again. Pretty standard trend, as you see with these reactions. And on the opposite side, we're just going to have the H bond here. So we have nothing more than, all right, a methylamine. Erase that goof. Okay, so as you can see, these all go the same way, and we have the OH of the water always adding to the carbonyl side. With the only exception of the base hydrolysis, we have the sodium and oxygen adding to the carbonyl side, and the lone hydrogen is left to add to the non-carbonyl side. So let's take a look at the opposite of these. Each of these would be esterification. We're going to make the esters and not break them apart like we were doing with hydrolysis. All right, so number 5, we have, what is this? Let's see. We have an alcohol. All right, so this is just ethanol. All right, so we are looking at the reverse of what? Ethanol, and here we have a ethanoic acid, so this will be the opposite of 1. So if in number 1 we had water split up, we're going to form water here, and pretty simple. We're going to take the OH group from the acid, and we're going to react it with the H from the alcohol, forming water, and bonding these together. So this O will then bond to this C, giving us the ethyl ethanoate that we had before. Same thing here. We're going to see this OH and one of these H's here come together, and we're going to have water. Ran out of room there. And we have the N-ethyl. In this case, well, we started with, this one would have been propanoic acid. So it's not a reverse of one of the ones we did before. Here we had the ethyl amine. All right, and we formed water. And let's see, we have this ethyl group bonded to the N, so it's going to be N-ethyl. And we have 1, 2, 3. So the amide side is propyl, propanamide. So N-ethyl propanamide. All right, and finally, let's look at this last example. We have ethyl thiol, and we have ethanoic acid. So this is just the reverse of what we did in number 3. So hopefully we'll form that same molecule there. As all of these are going, we're getting rid of, or we're forming water. So these are water forming reactions. Quite often they'll be grouped in a category of reactions called hydration reactions, because they form water. And we get this thiol ester bond right here, thiol ester, and we don't need to name it. This is out of the scope of what you had to name, so there's really not a purpose for us naming it. So hopefully you can follow these reactions, the hydrolysis reactions of these esters, thioesters, and amides, and then the reverse course, the catalyst pulling water from these reactions. They're actually not hydration, they're dehydration. They're removing water from it. That's what they're called, dehydration reactions. So hopefully you'll see that how these come together, and hopefully also see how to name them better.